All right. Hello, everyone. Welcome to the second installment of our Career Insight series for the fall semester, Careers in the Physical Sciences and Chemistry. My name is Jihyun Ju. I'm an advisor and program coordinator here at Beyond Barnard, and we'll be hearing from three Barnard alums today. We have two in our virtual room, and hopefully we'll have our third joining us very, very soon. I want to just take a moment to say thank you to our panelists for making the time to join us. The bios of our alums I'm going to drop in the chat in just a moment. For our students in the room, there will be an audience Q&A toward the end of our program, and so feel free to ask questions in the chat or unmute yourself when the time comes. Okay, so just to get the discussion started, like to start off with introductions. What is your current role and what sparked your initial interest in the work that you're doing now? And Caitlin or Margaret, either of you guys can jump
in. Sure, I'll start.
Go ahead. Okay,
Sure. So yeah, my name's Caitlin Susky. Right now I'm a principal scientist at Joule Labs. And so I do aerosol science, aerosol chemistry, and things like that related to R&D and product development at Joule Labs. And what sparked my interest in aerosols and aerosol chemistry was, so when I was at Barnard, I became interested in chemistry. I majored in chemistry, and then for grad school, I wanted to do something related to like the environment and climate. So I studied atmospheric chemistry, and through studying atmospheric chemistry, I did a lot of aerosol work, aerosol chemistry, and then aerosol cloud interactions. And then I did two postdocs. In one of my postdocs, I also studied like characterizing aerosols, like shape, size, and chemistry from lots of different sources other than just atmospheric aerosols. And that got me interested more broadly in just aerosol science. And then at Joule, I wanted to do something also that like helped people in some way. So my work at Joule has been focused on understanding how e-cigarettes deposit in your respiratory tract and trying to like develop an aerosol type that you could basically inhale. You would get the nicotine or any other type of drug. So any type of drug delivery, deposit the thing that you want, and then exhale the rest. So basically trying to do the least harmful way to like give people a drug or something like that. So yeah, so basically I've just want to do work that helps people in some kind of way. And then yeah, aerosols are just really interesting to me, and I just naturally found my way there. So yeah.
I think similarly, I was interested in like environmental and just like having a positive impact. So my undergrad was in physics, and then I got a master's in electrical engineering. So in my master's, I did work with large power systems and like power grids and stuff like that. So now I'm working at a company that we work in the construction industry, and I basically do electrical design for buildings. So we do a lot of like electrification and like consulting as to what is the best way to design a building so that it has the least environmental impact.
Beautiful. Thank you both so much. Can you tell us a bit more about what your day-to-day work looks like? I'm sure our students are always really curious to know sort of more detailed elements of a job.
I can go first this time. Yeah. So my day-to-day, I work with a lot of other people. My job is very collaborative. So even within my firm, we don't just have electrical engineers, we have mechanical engineers, we have plumbing engineers, we have IT engineers, and we all kind of collaborate internally, but then we also collaborate externally, specifically with a lot of architects. We're typically hired by the architect. So we have a lot of meetings like internally, but also with the client, with the architect. So my day-to-day involves a lot of like coordination meetings, sitting down, looking at designs and kind of figuring out what can give and take where to make a design work. And then the other thing that we do that kind of impacts my day-to-day is once the construction starts, we're responsible for going out to the construction sites and like taking a look and making sure that they're meeting our design and that everything looks correct and that everything is safe. So that's another thing that I do a lot.
Nice. Yeah, I think my day-to-day, it depends what type of project I'm working on. So right now, for instance, I'm working on a product development. So there's a lot of collaboration also. So I'm a scientist, so on the scientist side, but I work with a lot of engineers. So it's usually like engineers will have a question or they'll reach a point in the design where they don't know where to go. And then so we'll use the science to basically try and answer some of these questions they have to help them make decisions. So I'll do a lot of, so basically if they have a question, they'll come to me and we'll talk about it. And then I'll try to design an experiment to try to answer the question that they have. And then so from that stage, then we'll design the experiment, we'll do the experiment, and then try to get the answer back to them as soon as possible. So yeah, like quick experiments. And then also if there's broader questions that take longer, then that's a longer process. But then also, and then it's sharing out the data and making sure everybody understands it and documenting it and things like that. So people can find it later. And then if it's more of an R&D project and less really product focused, then that's a little bit slower paced. That side with engineers is pretty rapid fire, pretty quick turnarounds. And then if it's more R&D or thinking up, trying to understand the basic science of what we're doing or thinking up new possible directions for like products to be developed way in the future, then that process is more, thinking and researching and doing experiments to, yeah, like I said, understand the basic science. So it really depends in like what phase we're in, what the day-to-day looks like.
I feel like both of you guys are touching on all these skill sets that we talk about really commonly here at Beyond Barnard: the communication skills, collaboration skills, and of course, like the research as well. Building off of that, thinking on your career trajectory thus far, what skill sets have been most transferable to sort of the various roles that you've held and pursued? And another question tagging on to that is, what opportunities did you find to be sort of nourishing for you in getting involved in your current field?
Should I go first this time?
Yeah, go for it.
Okay, sure. So okay, skill sets. I definitely think just being curious and seeing opportunities to try to use science to help answer other people's questions or your own questions, and figuring out how to distill like from that question a way to answer it, or like experimental design or things to try to answer that question, and especially in industry, I think knowing how to do that quickly has been really helpful for me in my career. A lot of times I've heard engineers or other people complain about scientists that they take too long to like do things and think too much and try to do things too perfectly. So like really figuring out how to get like the cleanest data, but the in the quickest way, and knowing where you can go fast and where you do need to spend the time has been really valuable for me. Also, yeah, like everybody always says it, but like having a network of people to reach out to and ask questions to, especially if you're job searching, but even if you're not, just like getting mentorship from people outside of your company can be really useful and helpful. And I've found that everyone's always said that, and I haven't done a good job of that in the past, but recently I've been trying to do that more, and it's been really good and really helpful. So just echoing what everybody says about that. And then should I answer nourishing, or do you want to answer about the skill sets first?
Yeah, we can kind of break it up into two. Sure. So I absolutely agree with the questions. And I think even before like knowing how to answer questions, knowing to ask questions, and being comfortable asking questions, like it's so important to be able to like go to your boss or go to someone else you work with and like be able to ask questions and know what questions to ask and kind of what to do with that information once you get like the answers to those questions, and kind of how to apply that to what you're doing. because like, you know, I've definitely ended up in situations before where I'm like, I don't even know what the first question I should ask here is, you know, like I don't even know what I don't know. So just being able to recognize what you need to find out and like what you need to ask, and then who would be the person who could help you answer that question, and like understanding your resources. And then communication, I think, has also been like a huge one. And like I said, I work with like so many people every day. And it's so important to be able to communicate, especially when working with like a client, and just knowing like what to say and what not to say and what's appropriate, what like is acceptable to ask the client or to tell the client, and what needs to be like kind of reframed and said in like a more professional way. And just knowing like when, like what level of professionalism to communicate with, has been really important for me.
Yeah, and I'll just to follow up what you said about, yeah, knowing your resources and who to ask. Like that was something that I struggled with early in my career, being like, oh, well, this person might know, but I don't really know them and I don't want to waste their time. But if you just ask people, like the vast majority of the time, people want to help and are interested in like sharing their knowledge with you and stuff. So don't be afraid to ask people that you don't know or who are at a higher level or whatever. Usually those interactions go really well and are really good. So.
Absolutely.
And then, okay, I guess I'll answer about the nourishing environments. I think, well, Barnard was a very nourishing environment for me. I always felt very supported there in the chemistry department. And I think my time at Barnard really gave me the confidence to go into science and to feel like I could do something with my career in science. And then also I did a postdoc at Colorado State University in the atmospheric science department, and that department was really great as well, and they had very warm environment, very collaborative. You could really go up to anyone and ask questions there, and everyone wanted to talk and like help each other, and that was a really nice and really nourishing environment. And more friendly than other environments I've been in. And I think one thing I've noticed too is like if you're trying to decide between two different things or two different groups or whatever, look for the people who are happy because or like happier, because I feel like that really helps, like, you know, science or STEM fields in general, there's tedious parts to them and they can get difficult at times. But if you're around people who are happy to be there and nice and friendly, at least for me, that made all the difference in like keeping me motivated and like getting through those like tedious or like harder times.
Yeah, I absolutely agree that Barnard was really good for my confidence and just for like nourishing my interest in science. And like I said, I was a physics major, and the physics department, at least when I was at Barnard, and I think it probably still is pretty small. And so just having that like small cohort with the professors like who I knew so well was really good for me. And just like knowing my classmates that were in every class I took, even when we went over to take Columbia classes, like we kind of stayed within like a little Barnard cohort, and that was really nice to just have that feeling of support. And then even once I kind of realized I didn't want to do like hard physics and I wanted to do something more applied in the engineering field, the Barnard professors were all so supportive, and like they helped me figure out like what I needed to do and like what internships I should be looking at. And I started kind of taking some classes at Columbia's engineering school to kind of like feel it out. And even over there, like I had professors who were so instrumental in me feeling comfortable there, and like feeling like I wasn't like out of place among all of the engineering students. And yeah, really just having like a network of supportive people, I think more than a specific opportunity is what like nourishes that.
Thank you both so much. And just thinking about like nourishing environments. Caitlin, I love that you mentioned sort of the environmental factor here. I know both of you guys pursued graduate school, and a lot of our students, there is always that question, do I go to graduate school? Do I not go to graduate school? And so in thinking about your decision to attend graduate school, to apply, what are the components that you considered? And I also want to ask, because Caitlin, you mentioned the post-bac opportunity that you pursued following undergrad, and Margaret, if you have a post-bac opportunity to speak on as well, I'd love to hear what sort of drove that decision as well. And anyone can jump in.
I can go first. Yeah. So I didn't do any kind of post-bac. I went straight into a master's at Columbia, and I did a 3-2 program with the physics and engineering department. So there wasn't any other kind of thing in between. But for me, the reason that I decided to do that was that I knew I wanted to go into engineering at that point, and I felt like I didn't really have the right background with just a physics degree to be able to go into an engineering role. So I felt like I really needed a little bit of extra background, a little bit of extra coursework to feel like I could apply for those positions and feel good about my chances of getting them. So it made a lot of sense for me to go straight into the master's because of the joint 3-2 program. I think, if I had gone to an undergrad degree in engineering, I probably wouldn't have felt the need to do that. But with the liberal arts background, I think it really helped me kind of feel like I rounded out my applied engineering skills before I started working.
Can I ask you, what is a 3-2 program? I've never heard of it.
So there's so Barnard and Columbia, and I know Columbia does it with a lot of other programs as well. There's at least again, when I was there, they had kind of a program where you could do 3 years at Barnard and then 2 at Columbia and they have a couple iterations of it, and I'm not sure which one still exists now. There was one where you got a dual bachelor's, and for me, it was going to take the same amount of time to get a dual bachelor's as it would take to get a bachelor's and a master's. So I didn't do 3 and 2, I did 4 and 1. So I did my 4 years at Barnard, and then because I started some of the coursework in my senior year at Barnard, I was able to finish the master's then in 1 year. And that was really nice. And it it was a really cohesive kind of thing, at least compared to what it would have been going to other schools if I had gone to NYU or something like that. So that was a really good opportunity for me to feel like I could easily transition from physics to engineering.
Interesting. Yeah. Okay. So I said I did a postdoc, just so I didn't do anything in between. Yeah. In between college and grad school. I went right to grad school, and I did that because I knew that I wanted to do chemistry, and I knew I wanted to do something to help people, but I didn't know past that. And I think it's pretty, at least in the chemistry department, they did encourage people to go to grad school. If you didn't, some people did go right into industry from undergrad because they knew that's what they wanted to do. I didn't know exactly what I wanted to do, so it made sense to just keep studying chemistry, but go, be in a direction that I knew I wanted to go, which was environmental or something related to that. And then in terms of, I did kind of struggle with where to go to grad school and how to figure that out. So some advice I got, because I wasn't sure oh, should I go more for the school or should I go more for the professor and the research they're doing? And I think I was kind of told both, consider both. But yeah, ultimately I ended up going for the professor that I liked the research the most. And I think that's a good decision, because you really do have to if you're going to go to grad school, I think you need to especially for a PhD, you need to like what you're doing, and that needs to be the number one thing. But also you should like the group that you're in, because that's one thing that I didn't put as much emphasis on when I was deciding. I wish I would have done a little more, is yeah, make sure the group dynamics are good and that in general the grad students are happy or like what they're doing. I think that's important to look for as well. And then yeah, for my postdoc, actually did 2 postdocs, but for my first postdoc, I went towards, so I studied atmospheric aerosols and aerosol cloud interactions in my PhD. And then I got interested in ice nucleation or ice formation in clouds through that work. And so for my first postdoc, I did ice nucleation research. And then after that, I did another postdoc because I was doing long distance and I got married and I wanted to move where my husband was. So then I did another postdoc where he was at. But through that and just trying to do, things that made sense with like atmospheric aerosols and things. And through that and the work that was going on in the group that I joined there, that's how I broadened my scope of like what I was interested in and other types of aerosols. And then in choosing to go to industry, I kind of, I knew I didn't want to be a professor, at least at that time. And then it was hard to find jobs at like national labs, which is what I wanted to do because it was during the Trump administration and like anything related to climate change and things like that were like funding was kind of not cut, but they were worried it was going to be cut, and there were like hiring freezes and things like that. So I was like, okay, I guess this is the time to go to industry. And then in trying to figure out where to go in industry, there's a lot of like repetitive work, I think, in industry, like method development and then running a bunch of methods. At least this is chemistry specific, I mean. And so I knew I didn't want to do that. I wanted to do something a little more broad and more like inquisitive than just running methods. And so that's how I ended up in like R&D. So yeah.
Beautiful. Thank you both so much for, I know I threw that question your way sort of out of the blue. And you guys have been given like so much valuable advice thus far, but just to give that a bit more space, what advice would you give to students who are interested in pursuing a career in the physical sciences and chemistry, potentially even like in your specific sort of roles as well, but are unsure of where to start?
I would absolutely say like just try things, like, learn what you can, like watch YouTube videos to see what you're interested in, but also like internships I think are instrumental. And like even for me, I didn't do an internship in the industry that I'm in. I did an internship in aerospace, and then I realized that wasn't really what I wanted to do. And that was so helpful for me in just understanding what I didn't want to do. And an internship is so nice because it's like, 3 months and then you never have to do it again if you hate it. It's not like a big commitment. You get to learn what they're about. It kind of gives you like a little bit of a sneak peek. And then you can decide, okay, I want to do this, or this is what I did like about it. This is what I didn't like about it. And it just gives you, I think it gives you so much information that is so hard to get otherwise. So I would absolutely say like, try it, try an internship, do like a program if they have like shorter programs, anything that kind of gives you the chance to check things out, see how you feel about them, and then kind of regroup.
Yeah, I think that's great advice. Also, just even like if you're, even past that, like, you don't have to stick with a job forever if you don't like it. So yeah, try whatever seems interesting to you or that like, yeah, that you're passionate about. And then if you find out, yeah, you don't like it, like you can change. It's never too late to like change course. And even mid-career, I see people doing that a lot, just like, it's fine. And it's actually, I think, beneficial to have a lot of different experiences. It makes you like more well-rounded, and I think can help with problem solving and things like that if you have varied experiences. So yeah, I would say just follow what interests you, and yeah, try a bunch of things out until you figure that out if you don't know what interests you yet.
Fantastic. For students in the room, we are reaching our last question, and so please start preparing yours. Once again, you can drop them into the chat. When the time comes, you can also unmute yourselves and ask our panelists questions, lots of questions. So what are your hopes for your own career and for your profession in general?
Okay, I'll go. I think, I don't know, that's a hard question for me. I mean, I just want to be, I just want to have fun, I guess. It like, follow interesting questions, work with interesting people that I can learn from, just keep learning. That's really what I hope for my career. And hopefully do things that help people in some way. I think that's always what keeps me motivated in the times that are more tedious or hard. And for what was the other part of it? Your career and your
And
field.
your field generally.
Yeah, I think for chemistry or aerosol science, I think, at least in academia, I think funding is getting more difficult. So I hope that changes in the future and that people have more leeway to do interesting work and not just following the funding that is hard to get. And then in industry, I think, so I'm in the San Francisco Bay Area, and there are a lot of jobs in science and industry out here, but they don't pay very well for how expensive the Bay Area is compared to like the software or engineering jobs. So I would really like to see the scientists valued more, at least salary wise, and be given opportunities to do interesting work as well in R&D. So yeah.
You're absolutely right. This is definitely the hardest question. Like looking forward is always harder than looking back. But I think, I guess starting with my field, I'm excited to see where like the push for clean energy goes. I'm excited to see like what new technologies are developed and what can be implemented into like our power grid and buildings, and how that's going to impact the next 10, 20 years. Just especially in New York, where we have like so many buildings. It's such a like hot spot for my job. So I'm really excited to see where that goes, and what that looks like in 10 years, because even like talking to other people I work with, I feel like my job is so much different than what they were doing 10 years ago, just with so much new technology. And then for myself, I think I just want to, work on and make sure that I kind of stay caught up with all that stuff. It's really easy to get kind of caught up in old stuff and not embrace innovation. So I think, I really want to make sure that I'm like, still reading up on the news and reading up on like science journals and understanding like what there are new opportunities for, and helping implement those and share those with others. And just kind of understanding how we can make like our buildings greener, and how we can make our city greener and like long lasting.
Thank you so much. I know it was the most loaded question of the panel. So I know that we have Stella, who's one of my advisees in the room. Stella, do you have any questions for our panelists? Not to put you on the spot.
I do. I have a few questions. I kind of wanted to know a bit more about like the considerations that either of you had about going into like industry work or research focused work, rather than, I think, like you said, kind of repetitive tasks that can also be part of those kind of considerations. I kind of wanted to know more of what you're thinking, because I'm a chemistry major. So that's one of the things that I have to kind of think about, is whether I want to go into research or industry or applied sciences.
So for me, it was kind of, do I want to get a PhD or not? And in that, at that point, I decided that wasn't something I wanted right now. I wasn't so interested in like the technical research so much as the application of it. So for me, it didn't really make sense to get the PhD and to go into research as much as it did. Like, I really like hands-on things where like it's not like as much red tape as much as like being able to just try things and see what happens. So that was kind of how I ended up in the master's track instead of the PhD track. And I think that just within itself kind of defined that I kind of went towards industry rather than towards research.
Yeah, and I think for me, I kind of get bored quickly. Like if I'm doing the same thing over and over again, I get kind of bored. So for me, I knew I needed to go to grad school at least, because I didn't want to be doing the same thing. I didn't want to, usually like what I've seen is like people right out of undergrad who go into industry in chemistry will be given like an instrument and a technique and or a method, and you're just running that method on a bunch of different samples. And then over time you do gain expertise and you can get into doing more interesting work or more varied work over time. And you probably get there faster than if you get a PhD and then go into industry. But there is that period of time where you're doing that kind of repetitive work, I think. But some people really like that. Some people are like, yeah, I want to know everything about this method and this instrument, and that's really engaging for them. For me, it was not. So I was like, yeah, I want to be asking questions, so like constantly keep asking questions and going towards different things and learning different types of things. So that's why I chose to go to grad school. And then also why I was very intentional in choosing my job in industry, to make sure that, because even if you have a PhD, sometimes it just becomes repetitive work as well, just at maybe more complicated repetitive work, depending on, whatever the business need is. A lot of business needs are just running samples over and over, like asking, you have a new question, so you need to develop a method to address that question. And then after you have the new method, it's repetitive. But yeah, I think you just have to think about what you like doing and or what type of work you like doing, and then that can hopefully guide you towards what's the best thing for you.
Thank you.
Stella, I know the questions that you have are questions that other students have as well. And so if you have more questions, please feel free.
Yeah, I kind of wanted to know a little bit of like how much of your job is influenced by like your ability to keep up with scientific literature and like developments that are happening in other labs and other fields and stuff like that. Like how much of your job and things that you're doing are like dependent on your ability to not necessarily do outside research, but keep up with surrounding literature.
Yeah, I think for me, at least, so the company that I'm in and the field I'm in right now, not a lot of people publish about this. So I would say I do go to scientific conferences and things and try to keep up with what's being published, but there's not a ton that's being published, I would say. So I think it's important to keep up with it, but it's not as important as it was for me like when I was in academia. I think there's less of that, and it's more of the keeping up internally with what's going on at the company and knowing what other groups are doing and how I interact with them. I'd say that's probably more important for my work right now.
I think for me, it's less of kind of keeping up with literature and the technical aspects, but more keeping up with the implementation. So my company does this great thing where they have like what are called lunch and learns. So they have people from different companies who have like new technology or like updates to their technology of things that we use a lot of the time. They come in and like they kind of talk to us and we eat lunch and we have like kind of a chat, and it's kind of like an information session about new technologies. So it's really nice that they kind of like make that available to us rather than us having to go and seek it out so much. But it is a lot less about like understanding exactly how this works and being able to read a paper about it, and more about, okay, I know how I can use this in my design, like moving forward to make this product, or like not this product, but this like building or this system better.
Thank you.
Other questions, Stella?
Yeah, when you're kind of looking into your job, and I guess this is more of like in recent years, science has become very like computationally focused, even like chemistry, which you think of as like, oh, you're sitting in a lab and mixing chemicals. It's not really that anymore. It's very like computer focused and algorithm focused. Are there opportunities for you when you're pursuing graduate school doctorate, postdoc, and when you're going into industry and other sort of opportunities, are there ways for you to learn, like have you found that there's ways for you to integrate computational stuff in and learn it along the way? Or is it more of a thing that you had to start learning early on how to integrate computational work into your kind of pure science degree?
You want to go?
Yeah, sure. So something and like, I know that you said you're a chemistry major and not physics, so I don't know if this will 100% apply to you, but hopefully somebody watching it'll be helpful for. Like one of my biggest pieces of advice is to learn a coding language. Because once you know one, it's so much easier to learn another. It's so much easier to like follow along just with the logic that goes with that. And it's so applicable in so many different places, whether you go into hard science and you go into research or you go into industry. Like just understanding how a coding language functions is so key. And you know, I definitely don't feel like going through grad school and into industry, I was like, you know, spoon fed like every single kind of technology, but there are different ones that kind of played key roles as I moved along. Like when I was in grad school, the research that I was working on was all like completely analytically done in Python. It was all like model based. There was no like physical research going on. Like we were using data and we were analyzing it. So that kind of helped wrap that into my understanding. And now like I don't use Python anymore, but I still feel like if I sit down and I look at it and like I can jog my memory and it comes back, and like even if another coding language kind of comes into play or another program with a similar kind of structure comes into play, it's a lot easier for me to pick it up. And now like at work, like I said, I don't code, but we do use a lot of like technology. We use a lot of like computer programs that kind of help us create models and stuff. And just having a background in that kind of thing really helps learn a new one.
Yeah, I think I definitely agree. Unfortunately, I think everybody needs to know how to code in the modern world. In grad school, I guess I was lucky in a sense that, yeah, my PhD is in chemistry, but I was in a group where we were doing field studies and things like that. And we had the main instrument I used was like a single particle mass spec. So we would have like mass spectra of like millions of particles for these field studies. So I had to learn how to code in grad school to do data processing and handling of all that data. And I'm glad that I did, because a lot of people who did more like, yeah, like organic synthesis and stuff like that, they didn't have to learn how to code in grad school. So like I had to teach myself how to code, but then, you know, that's a good place to have to do that in grad school when you have time to learn and things like that. And then, yeah, so I learned MATLAB then, but then I agree, it's easy to switch to other languages. Like now I code all in Python. And I do use coding in my job here too. Like I think, or even just for, yeah, data processing and plotting and things like that. And Python's great because it's all free and open source. So if you change jobs or go from different research groups to another, you don't have to wait until you get the license or make sure that they are getting the right license or whatever. Like it's all free and stuff. So yeah, I would say try to start to learn to code as early as possible and use it where you can, because yeah, I do think it is really important in the sciences now. And I think it will put you, especially as a chemistry major, it will definitely give you a leg up versus other chemistry majors who don't code, because I'm sure at some point in your career, you will have to use it. Or even if you don't have to, I still think it makes some things easier and could be faster. So also gives you a leg up in that sense.
So interesting. Stella, we have time for maybe 2 more questions. If you have additional questions, fire away.
I don't have any more additional questions. I think they've answered pretty much anything I could think of. Thank you both.
Yeah, absolutely.
Yeah, thank you for
Wonderful.
the questions.
Well, thank you again, both to Caitlin and Margaret, for joining us today and providing such thoughtful insights. Stella, thank you for your thoughtful questions. I know all of our students, all of those who registered but weren't able to make it today, are going to be watching on YouTube. It's going to be immensely helpful for all of them. For our panelists, you'll be hearing from me. I'll put you both in an email, so contact information can be exchanged amongst you both. And we hope to see you at our next Career Insights event. Have a great rest of the day. Thank you all.
Thank you.
Thank you.
Thank you.